We are glad to share you with our research. Millimeter wave, fully metallic, leaky wave antenna with backfire-to-forward beam scanning, high scanning rate, and high efficiency. The overall topology of our purposed antenna is showed here, which can be divided into two parts with mirror symmetry. The antenna consists of feeding structure, slow wave transmission line, and transverse modulation slots. The first main contribution is the theoretical conditions of backfire-to-forward beam scanning. Specific requirements of dispersion, period of the modulation are provided for guidance. The second main contribution is a more dispersive slow wave transmission line, which indicates a higher slope of phase constant to the frequency. The third main contribution is to correct beam deflection near backfire region, and the final main contribution is to suppress open stopband effect. Based on a structure evolution, both dispersion expressions and simulated results indicate that the proposed DCPPW exhibits more dispersive performance. Then, the slow wave transmission line is developed and acceptable transmission performance is obtained. The theoretical scanning range is from -90 degrees to +19 degrees. Transverse modulation slots are loaded on the transmission line as the radiation structure. To avoid the obstacle of backfire radiation, feeding structure is designed in -Z direction. Good impedance matching and beam scanning capability can be observed from the simulated results. However, two problems should be noted. The first problem is the beam deflection near the backfire region due to edge diffraction effect. The second problem is the mismatching and gain attenuation in the broadside direction due to open stopband effect. To solve the first problem, slopes are added to both ends of the antenna. For instance, the beam direction at 26.5 GHz is corrected from -82 degree to -90 degree. To suppress the open stopband effect, asymmetric grooves with different depth are employed. As a result, the drastic change of real and imaginary parts of block impedance are eliminated. The normalized leakage constant and peak gain in the broadside direction are significantly improved. The prototype of the proposed antenna is shown here. Good impedance matching is achieved. Measured results show that a beam scanning range from -90 degree to +11 degree is obtained with the scanning rate reaches 2.49. Radiation efficiency keeps higher than 90% within 95.6% of the operating bandwidth. A comparison with related works in open literature reveals that the proposed antenna solves the problem of backfire-to-forward coverage of fully metallic leaky wave antennas, together with high scanning rate and radiation efficiency. Thanks for your attention.